So yeah, welcome to this session of the Hugging Face Computer Vision Hangout in October 2025. Right, the last one was in June 2025, which is some months ago, and I didn't want to have a break for that long. Actually, I just thought we'd do a little summer break because everyone is off anyways. But it happened just to become a bit of a longer break. But I'm happy to be back with the Hangout, and yeah, to have some people join. What we usually do here in the Hangouts, I think Lane already said it just now, is like first we talk, okay, what's new in computer vision at Hugging Face? And it's been a long time since the last Hangout, so there's a lot that happened, and I tried to put together, well, the most interesting things, I would say, in this presentation. There's probably a lot of stuff still missing, so it's not like completely comprehensive, but I guess it's interesting enough, and I also don't want to make it too long because I'm really looking forward to the presentation by Lane and Ed afterwards. So we'll talk about vision language models and give us a bit of a closer look. And yeah, I'm really looking forward because I think I will learn quite a lot from it. And yeah, that's enough talking about that. I just start right with what's new, right? And we start with a section about new models in transformers. I guess everyone knows the Transformers library from Hugging Face around here. So yeah, from time to time there are new models, right? I don't know how many models there are at the moment, but it's like huge already, and they're still getting more. So one new model in Transformers, since we last had the Computer Vision Hangout, is Light Clue, which is a model that is used for local feature matching. Oh yeah, maybe I should say, I mean, we're Computer Vision Hangout, so we mostly look at computer vision models and vision language models, right? So it's not like every new model in Transformers, it's more the computer vision related models. Okay, so yeah, Light Clue is used for local feature matching. As you can see in the image, right? Basically you have two images, for example, and then you try to find some key points again in like both of the images and connect them. There is like here's some more info about it. There's a paper, there's the docs, the transformer docs, and there's also a demo right here from ETH. And basically you can just select some examples. For example, oh no, this one is a bad example. I tried it yesterday. It's not the best. Let's use this one. Maybe that one is better. So you have like two images of Tower Bridge, I guess. And you run match images, and then you get it here, and it looks pretty good, actually. So yeah, you even get like a score with it, like how good it is or how certain it is, some confidence score, I guess. And then you just get your pairs of points in these two images. A pretty nice one for some, old school computer vision tasks, I would say. Okay, let's go on. Next model is GLM 4.1V Thinking, which actually is a visual reasoning model. So I feel like visual reasoning is still a bit underexplored in a way, but there have been a lot of papers looking into it, but not really a lot of popular models coming out from that, at least in my feeling. Maybe I'm wrong about that. So yeah, I mean, visual reasoning models is mostly, in a way, vision language models that can also kind of do reasoning. Like we know from most LLMs these days, they can do reasoning. And yeah, for example, this one is trying to also apply some reasoning logic to VLMs, basically. Also here is paper, is a docs, and there is a demo which is using API actually, because I couldn't find a demo that is really just running it on zero GPU or something. So here's an API demo for it, and it doesn't have examples. And to not make this whole thing too long, I will not upload anything, but you can try it out if you want to try out a visual reasoning model, right? And there's another tightly related model. It's GLM 4.5V, not thinking here, you see. So it's, you could say a basic visual language model vision language model, actually, not visual language. But yeah, you get it. Yeah, and you might say, hey, it's the same graphic as before. Yes, because the architecture didn't change much between the both GLM versions. And actually, they share the same paper. So also, like when you go here and you click on paper, it's the same paper as before because they are in the same paper, actually. And yeah, there's also a demo down here. Well, it mostly does what vision language models do, right? So it's just a good one, and you can use it in transformers. I think there's not that much more to say about that right now. It uses mixture of experts, right? That's why it's in like the transformer docs. It's called GLM 4V MOE, right? So yeah. The next model. I said there's a lot, right? And I was not lying because there will be many more. Is EOMT, encoder only mask transformer, which is a really interesting model because it's just a segmentation model, but it tries to do a radically simple approach, I would say. So this image here, Niels from Hugging Face used it in his LinkedIn post about the model. It's basically showing, okay, previous methods, they for image segmentation, they use a lot of stuff, right? You've got a vision transformer, then you've got adapters and pixel decoder, and then some other decoders on top. And you just need to plug in a lot of stuff into a vision transformer to get segmentation. And EOMT basically is just using a plain or vanilla vision transformer, right? And they just use this vanilla architecture without any additions to turn it into a segmentation model. And yeah, they were successful. And that's pretty cool because it's just way simpler than a lot of other approaches. So yeah, if you want a real simple segmentation model, you can check out EOMT, a demo as well, over here. So here we have our examples. Let's try this one, for example, the bike. And you can choose, even some visualization type. Let's just do mask. It's good enough. And let's go. So you see the model is Coco Panoptic EOMT large. Probably trained on the Coco Panoptic dataset. Yeah, and it does segmentation. It might not be like the most detailed thing, right? You might be like, oh, it's okay. But yeah, therefore it's quite a simple one and not heavy on the compute, I'd say. Okay, let's go on. Next one, actually two, LLM-DET and MM-grounding Dino. Both are zero-shot object detection models. And MM-grounding Dino is basically an advanced version of the grounding Dino model, and it's open source, the MM1. And LLM-DET is basically an advanced version of MM-grounding Dino. They were just added at the same time to transformers. So first there was MM-grounding Dino and then LLM-DET. And if I remember correctly, LLM-DET even was a spotlight paper at the CVPR this year. Again, I might be wrong, but yeah. So what they do is zero-shot object detection. And zero-shot object detection means, right, you can basically just use the model and ask it to detect stuff it might not have seen before, or just ask it anything, and it tries its best to detect that stuff, even though it might not have been in their training data set. That is pretty cool stuff. I only found, basically there's no real separate doc for LLM-DET. You only find the MM-grounding Dino doc in transformers. And for demos, I also couldn't really find LLM-DET one. But yeah, I mean, in general, you can just try out the MM-grounding Dino one and then just believe that LLM-DET is better than that. I mean, as they share an architecture, you basically just need to use just load the model, like the weights with the same MM-grounding Dino class from transformers, and then you can go and does what it does, right? You prompt it something you want to see, and then it tells you where that stuff is. Okay, next one. SAM2, yes. So you might say, wait, SAM2? I've seen that before. It's not new. And you're right. It's not a new model, but sorry. But it is new in Transformers, actually. So yeah, so far it hasn't been included in the Transformers library. And now it is. Now you can use SAM2 from within Transformers, and also the video version of it. So SAM2 video. Yes, and probably, well, you know that it's a promptable segmentation model. That means you can basically choose in a start image or whatever what you want to segment. Like here you have this skateboarder thing, right? And yeah, then you get this segmentation from it. And here the demos are really nice, actually. So there's one for video and one for image by Sylvain, right? Sylvain Filoni. And okay, he didn't put examples here, but go try it out. I think for the image was there an example? No. But I wanted to try something, right? I wanted to try the webcam feature here, because you will see me in a second. Let's see if you can see me. It's dark. It's dark. It's still dark. It's not working. Oh, wrong camera. This one. Hey, hello. It's me. And then you can take a picture of that. Okay, that's very blurry. I look stupid. But we can put a point, for example, on this plant, or whatever. And then we can use a bit of a better checkpoint, submit the whole picture. It's running on 0 GPU. I'm cute. And then we wait. Okay, and then we see the segmentation mask down here. Okay, it segmented a bit more than it should have around my hair here, right? But yeah, it's pretty nice, I'd say. SAM2. Okay, let's go on. Florence 2. There's another model you might have heard before and might be like, that's not new, but it is new in Transformers. And I would say it's one of my favorite, vision language models. So here it says vision foundation models. Still, even though it is maybe a year old or something. But it is quite lightweight and it can do a lot of stuff for its size. It's really good at captioning, for example. So it's a really cool model if you want to run captioning actually on some production workload or something. Florence 2 is always a good go-to solution. And again, paper, docs, the demo. Have a look if you're interested. I won't do it now. And then there's one I'm really excited about, because that is really new. And it made its way to Transformers really fast, and it's called MetaClip 2, right? So I guess everyone these days knows Clip, right? Because Clip is like I would say the OG of vision language models, right? The first one that really did vision language models successfully. Now, the problem is like the usual Clip or most other Clip versions as well is language, I would say. As someone who lives in Germany and works for a German company and has to do a lot of stuff with the German language, right? I just can't use English trained clips that well, or I would have to translate everything or whatever. So this is what MetaClip basically tackles, or MetaClip 2, because they are multilingual and they have 329 languages, they say down here, on which they trained MetaClip. And I haven't tried it yet, I have to say, right? So I can't say how good it really is on German, for example. But I would expect it to be better than Clip with some translation in front of it. So I would definitely try that. I just found out yesterday that it's in Transformers. And I was like, oh, shit, I have to try that. So And there's no demo yet. I also saw that. I searched the hub or like the website Hugging Face for a demo for MetaClip 2, and there is none yet. So if anyone's interested in building a cool demo, this is your chance, right? Just have some different languages lined up somewhere to try and embed some data set. I don't know, like a fashion data set or something. And then, build a demo with MetaClip 2. And everyone will love you, I guess. Maybe. Okay. Oh, yeah. And then that's not a new model in Transformers, but it is a new pipeline. So it's a key point matching pipeline. If you remember the first model I talked about, there was key point matching with light clue. And if you're familiar with Transformers, you probably know the pipelines, which are basically the easiest way to get a task done. So there, for all kinds of tasks, you have pipelines. And now there's also one for key point matching. So if you want to run key point matching, just click on this thing here. And then you can see, just use these few lines of code. And then you can basically throw in some weights that you want to use for the key point matching. So some model here. And then, it does everything for you, basically, which is nice if you want to use key point matching for something. I think this was even a community contribution. So someone from the community decided, hey, I want to have this kind of pipeline in Transformers. So he started working on it, and then he just contributed that to the code base. Yeah. Which is always a nice thing, right? If you have something like you think is missing, and you can open an issue, and then people will talk to you from Hugging Face and find out if that makes sense. If it does, you can contribute as well. And something I've never noticed, but maybe people that use more video stuff than me have noticed, is that so far in Transformers, there was no real video processor. So everything was basically done with the image processor. And for videos, it was just kind of, I don't want to say abused, but it was just used to somehow hacky make it work for videos as well. Now there's a dedicated video processor, which is supposed to be a lot faster and a lot better to use if you're doing stuff with video. And I think that's great. Yeah, I also haven't tried it, but it exists. Okay, next section, new demos and projects. Take a quick drink, sip. And then we go on. Okay, the first demo by Sergio is about VLM object understanding. Can I click the link without clicking the slides? Yes. So what you can do here is, for example, so you've got Qwen 2.5 VL 3B instruct, and then you can say something like, okay, we take this, detect all the individual candies in the image and return their location and labels, right? And then you can enter a prompt for Moondream 2. Moondream 2 is another vision language model. And you can say, okay, object detection, and say generate. And then, you wait a second again. Yes, great. Then you can see annotate image for Qwen 2.5 and what Moondream 2 did of it. Right, and you can compare the outputs basically of these two. You see, Moondream 2 is way better for like separated object detection. It's called instance detection maybe, than, for example, Qwen 2.5, because it just gives you everything together, right? Yeah, that's something you can do. Sergio build, and Merv build something. I don't know if the link is working. And this is for Dino V3. So maybe you've heard about the Dino V3 model. I think you should have heard about it. The other thing is, was one of the best models for, general computer vision tasks that came out in the last months. And yeah, Merve built something to actually look at what she calls it, patch similarity, right? I haven't tried to use it, so I'm not sure how to use it yet. But it should work somehow that you can see the patch similarity. Maybe. Now it's processing. You have to click on the picture. Yes. Okay, and then you can see basically what Dino v3 sees, like what's important for Dino v3 as, yeah, it sees images. Yeah, nice to play around with. Might come in handy if you have problems with Dino v3 and some images, and you can check out what it actually sees in these images that you have problems with. Yeah. And another thing, I think it was from Merve, she built a VJepper 2 video fine-tuning script and notebook. So if you want to fine-tune VJepper 2, yeah, you can check this out, the script and the notebook. And there's a lot of new data sets that the team built, Hugging Face team built around small dockling. I just linked the LinkedIn post here. Because it was a bit short on time, honestly. So yeah, you can check out the LinkedIn post. And this one is a great one because I also just found it when I was researching for the whole thing here. It's a repository about image deduplication, which is, well, one of the tasks, I don't know, at least I did a lot of times already. And this is basically a toolkit that the Hugging Face team used. And I think it's especially fast and is working really well. So here it says build around Facebook's SSCD, a self-supervised copy detection model. And yeah, it can detect duplicate images, generate perceptual embeddings, visualize dataset structure, and you can query similar images with it. It's quite a handy toolkit, I would say. If you need that, if you have a huge data set and you want to clean it, you can use this toolkit and get started. Okay, there are some cookbook news. The images are only half loaded over here. But Sergio, was really going crazy around cookbook recipes, I would say. So maybe you know the AI cookbook, open source AI cookbook, that's what it's called. It's basically a repository that everyone can contribute to. If you have a cool recipe for something and you want to share it, you can also here open an issue in the repository, then create a pull request and contribute your recipe to the open source AI cookbook. So as I mentioned, Sergio did that a lot. There are 3 new ones. They are all about VLM, so vision language models, and how to post-train them with TRL. TRL is another library by Hugging Face for post-training that has really leveled up in the past months concerning its vision language model abilities. So if you need to post-train your vision language model in a way, you can check out the cookbook recipes by Sergio or just go directly to the TRL library and check that. Yes. Oh, wait a second. Something up. Nope. Click on that. Here we go. Merve moved her small vision repository. So it's a great repository, actually, small vision, for all kinds around vision language models, especially small vision language models, of course. And she moved it from GitHub to Hugging Face to the hub because GitHub has some problems about Jupyter notebooks. And she also added some new stuff to it. So there's like a Dino v3 fine-tuning, and really interesting any-to-any rec. Right, so it's basically using any-to-any models. That means models that can take in a lot of different modalities, not just vision and text, but maybe vision, text, audio, video, all kinds of stuff. And then, she built this notebook here to actually do a video rec, for example, which is really cool. And if you're interested in building RAG systems with not just text or just images, I think this is a nice recipe to go by. Yes. Oh, and then there's the kernel hub. There's something you have to say, like custom CUDA kernels. I think they're really powerful, but I never wrote one myself. But if you are into writing CUDA kernels, you can check out the kernel hub. Or if you just want to use some from other people, you can check out the kernel hub and use their kernels to optimize your flows, I guess. Here it is. There's a whole blog post about it, actually. And maybe this makes it more accessible, because I feel like custom kernels are really one of the, most complicated things you can do these days around machine learning. But maybe the kernel hub helps in sharing and also learning, because you can see best practices and stuff like that. I will share the slides, absolutely, Mohammed. Just ask in the chat. They will be shared. I think directly after the presentation, I will share them in the computer vision channel here in Discord. So you can check that all out. You don't have to remember everything, of course. I'm just going through it once, so you've heard about it. But yeah. And next section. We're almost done. We're at 33 of 42, right? So, and I won't read the blog posts to you, right? I just mentioned them. So there are some blog posts, some new ones, like Pedro, who trained Marigold, another vision language model for text random segmentation. We call it Coco Gold. Another one is Timescope, which is really cool because it's about how long can your video large language multimodal go. This is basically about like maybe you can call it perception window of your video large language model. And another blog post about vision language model alignment, GRPO and MPO in TRL, which is a lot of abbreviations. It's mostly about post-training. What I also mentioned, we had a lot, Sergio created a lot about in the cookbooks. And then we have the category others, where it's just some stuff. Again, post-training. So there's, for the small course, maybe you've seen the small course in like the courses from Hugging Face. There's a small course and it got a lot of new material about post-training. Again, you see post-training and vision language models especially was a big topic in the last months, which is really cool because, it is important technique actually to run. And especially if you want to adapt it to your own data, the vision language models, you'd need to post-train it somehow, most likely. So now we've got a lot more stuff to learn from Hugging Face. And this is just, not nice. But Merve shared her slides about multimodal AI, which are also really nice to look at. You can check them out right on LinkedIn when you follow this thing here, this link. Okay. Last but not least, I've got a list of some people to follow from Hugging Face, right? So it's like Merve, I mentioned a few times, Niels, Andres, Sergio, Dylan, who's mostly into 3D. So if you're about, 3D models and AI, also like Gaussian splatting and everything, Dylan is the person to follow, I would say. And then there's Aritra, and there's also Sayak, who is mostly doing diffuser stuff. You might have noticed that I did not talk about diffusers right now, because there's been so much around the other stuff already that I focused on, the Transformers library mostly, not diffusers. I think else this would have taken a lot longer, but I don't want to keep us too long in this presentation because I'm really now looking forward to the next presentation by Lane and Ed, who also created a new blog post. I didn't mention the blog post here. Sorry, Lane and Ed, but maybe you will mention it now.